Good morning. I was going to move on this morning, but I'm grateful for your feedback, and I'm going to do one more session on hypothesis testing. It's a really big topic. It crops up again in year two, and I think it's worth just dwelling on it. So I've got this problem. I've got this coin. All right, I haven't handled money for a long time, but there we go. And I've just flipped it 20 times, and I got 6 heads. Okay, so I flipped it 20 times and I got heads 6 times. And my question is there something wrong with this coin? Is it dodgy? Okay, so if the coin was normal, if the coin was fair, we could say the number of heads I'm going to get is a variable. It's a discrete random variable, discrete because it's going to be a whole number. And it follows a binomial distribution where I'm flipping it 20 times and the probability is a half. And I know that if I worked out the probability of getting no heads, 1 head, 2 heads, 3 heads, 4 heads, I'd get a number of probabilities. And one way we've got of displaying that is with this sort of curve here. We know actually it's lots of lines, isn't it? Because each of those probabilities from 0 to 20 has a value, but we tend to sort of join it up. And I know that I would expect n times p, 20 times half, I'd expect to get 10 heads. That's what I'd expect to get. That's my expected value, sometimes referred to as the mean. And because the probability is a half, this is going to be a symmetrical distribution. Binomial is not always symmetrical. So I got 6. And so my question is the probability of this coin coming up heads a half, and I just had something unlikely happen? 6 is unlikely, only 6. Or is there something wrong with the coin? So my null hypothesis is that the probability is a half. It's just something unlikely has happened, and unlikely things happen. People get struck by lightning, people win the lottery, unlikely things happen. So that's one option. Or maybe my alternative hypothesis, maybe actually there's something wrong with this coin. It's less likely to come up with heads. So maybe the probability is less than a half. And so hypothesis testing is all about saying which of these is true. And the sad thing is that we have no way of definitively saying, yes, this is true, or yes, this is true. All we can do is look at the evidence. And so what we do in this one-tailed test, because we're testing if the probability is less, we're looking at this end, we work out not just the probability of 6, but all of these probabilities. So I'm going to do that quickly on my calculator, excuse me, and it comes out as 0.0577 if I round to 4 decimal places. Remember, all of these probabilities add up to 1. So the probability up to 10, that would be a half, 0.5. So this is pretty unlikely. This is a tiny, tiny, tiny number. So it's pretty unlikely. But is it unlikely enough for me to say, this can't be true, this must be true? And that's where the significance level comes in. Because if we are looking at the 10% level, then all I need to see is a probability here that's less than 0.1. And yeah, I've got it. So at the 10% level, yeah, I'm saying this can't be true. There is evidence to suggest that this is true. However, if I want to be absolutely certain, I need to use a more stringent test. So testing at the 5% level says alarm bells are only going to ring for me if the probability is less than that. And in this case, it isn't, is it? So in this, if I'm testing at the 5% significance level, I'm not going to reject the null hypothesis. I'm going to say this is unlikely, but it's not unlikely enough. And you've seen questions where we even test at the 1% level, where we need to be really, really, really convinced that something is amiss. So that's what hypothesis testing is about. And we're now going to have a look at some exam questions. I'm going to go through 2, and I'm going to ask you to do 2. So here's the first of the 2 questions. This is all about Roger and his bouncing balls. So while we all struggle to keep a straight face, I'll have a go at it. remember, the null hypothesis is the commonly held belief. And the commonly held belief is that when Roger does his ball bounce test, the probability of it failing is 0.2. So that's what we expect. We expect a ball to fail this test 1/5 of the time. And he's checking 40 balls. So the number he expects to fail follows this pattern. And we know that that's going to look something like this, although it's not symmetrical. 0 to 40, and we would expect 8. 8 is our peak. That's what we would expect to get. 40 times 0.2 is 8. A new supplier comes along and says, no, we've improved it. The probability of our balls failing is less. So Roger tests it. So the null hypothesis is that the probability is what it always has been. The probability of a ball failing is 0.2. The supplier says, no, we've improved it. We've reduced the probability of a ball failing. So that's our alternative hypothesis. So Roger does a check and he finds that 3 balls fail the test. Now remember, we don't just look at the probability of 3, we look at the probability of everything less than and including 3. So I'm going to work out the probability that x is less than or equal to 3. And I'm testing at the 5% significance level, so I need to see if that's less than 0.05. So here's my calculator set up for it. So I've got number of trials is 40, probability of success 0.2, although of course success is the ball failing, slightly hard to get your head around. Probability from 0 to 3, 0.0285 to 4 decimal places. Now, 0.0285 is less than 0.05. So this is just too unlikely. Okay, so we reject the null hypothesis. We reject H0. There is evidence to suggest that the probability is less than 0.2. So it looks like this new supplier has got a case to make. Of course, we're very careful here. We're not saying it is definitely less than 0.2. We're just saying there's evidence to suggest that. Here's the second question. It's only the second time I've taught this, so I'm sort of getting used to it as well. It's new to the syllabus. It used to be in further maths. Yeah, this is another question that talks about the probability being as close as possible to 2.5%. It seems that questions are pretty much 50-50 split between ones where you have to find a critical region where the probability is less than, or ones where you have to be as close to as possible. So I've deliberately chosen a close to one to demo, and the one I'm going to ask you to do is a close to one as well. But can you note the key difference here? We're not testing whether a probability is greater than or less than what we already think it is. We're testing just to see if it's different. So this is a two-tail test. So we're dealing here with something that's happening 25 times, and at the moment we think its probability is 0.5. So and 25 times a half is 12.5, so our peak is going to be around 12 and 13. So we want to work out the critical region now. So we haven't got a value, we've just got to find the critical region. So I'm going to start at this end and at this end, trying to make this probability here and this probability here as close as possible to the decimal equivalent of 2.5%, which is 0.025. And remember that they don't actually state the significance level here, but that's a 5% test, isn't it? Because remember, with a two-tailed test, you split your probability between the two tails. So we're testing at the 5% level, 2.5% here, 2.5% here. Right, I'm going to pause and work out some values here and see if I can work out what value here gives me a probability of between 0 and that value closest to that, and similarly between there and 25, a probability closest to that. So as I've said before, I don't like sort of leaving it like this, so I fill in the probability from the null hypothesis. So that's what I've been using on my calculator, and I noticed that if I make that 7, so the probability from 0 to 7, I get that. And if I make that 8, 0 to 8, I get that. So which of those is closest to 0.025? Well, it's 7. So I know my lower critical region is when x is less than or equal to 7. That's my lower critical region. So we're not given a context here. We don't know what this is about. But I know that any value of 7 or less, alarm bells are going to be ringing. The null hypothesis will be rejected. At the upper end, going from a value to 25, when I went from 18 to 25, I got 0.0216, and 17 to 25, I got 0.0539. So again, this is the one that's closest. So that's going to be 18. I don't know if you noticed, these two probabilities are the same. Does that always happen? No. It's only because the probability of success is a half, so we've got a symmetrical distribution. So in this case, our critical regions are the same size at both ends. So a value of 18 or more, or a value of 7 or less, would ring alarm bells and cause the null hypothesis to be rejected. And the last part of the question, this question, remember, can be asked in one of two ways. It can be asked in this way, or they may ask, what's the actual significance level in this case? And the answers to both questions are the same. It's these two probabilities added together. So it's this probability and this probability added together, which is 0.0432. What they're basically saying is, you know, any probability in any value in here, sorry, is going to cause the null hypothesis to be rejected. But values still could occur in here. They're unlikely, but they still could occur in here. So the combined area of those two is this. So that's the probability that you incorrectly reject H0. Okay, so I've attached 4 questions, these two, just in case you wanted to go through them with me, and then 2 further questions that I would like you to attempt. Take a photo of your solution and send it to me. It's Thursday today. If you could send it by the end of play on Friday, and you know, a number of you have been doing that regularly. Some of you have not, so please can you all do that. If you're a bit behind and you think, right, I'm not going to get it done, but I'm still keen to do it, email me and say when you're going to be able to do it by. Okay, but please don't ignore it and expect it to go away, because it won't. I do hope you are all well. I hope you have an enjoyable half term, and I will see you, well, you'll hear from me the week after that. Take care.